Hello friends, welcome to Susan and John MathTube. This is lesson number 4 and we are still on beta gamma functions. And as always, the most important questions while you watch a video lesson and the 5 most important points. So let's start with lesson number 4. Now look at this. In your first semester, you use beta gamma functions or the integrals mainly to evaluate the integral from 0 to pi by 2. And you might have sine or cosine or a product combination of sine and cosine. But some problems can be reduced into that format. That means the question will be different. And you can note the first question. Evaluate the integral 0 to pi by 8 cos cube 4x dx. So look at this. Sadly, we cannot apply the beta formula for this integral. The reason is limit is not 0 to pi by 8 and the angle is not x. But that's the trick. Okay, and I'll show you what happens. We put 4x is equal to t because I already found one connection between the angle and the limits. And I'll tell you the connection in a minute. Look at this. These limits belong to x, right? So, if x equal to 0, I think I'll write from right to left. That will be comfortable for you. Tell me, what is the t value? 4x. So if x equal to 0, t will be 4 into 0, that is 0. Now, if x is equal to the upper limit, pi by 8, what will be t? Yeah, that is exactly what made me do this substitution. What's the answer? Pi by 2. That's it. Now, don't forget, you have to take the differential. 4 dx is equal to dt. And dx will be 1 by 4 dt. So that gives me integral t is equal to 0 to pi by 2 cos cube t, and this dx is, where is my dx? 1 by 4. I'm going to keep that 1 by 4 outside and dt. That's it, my friends. And I'll repeat the same thing I told you in the last 2 videos. If the question is not related to beta gamma, in the sense, if in the question they have not mentioned using beta gamma, then go for that awesome shortcut in reduction formula. That is, you write 1 by 4, 3, 2, 1 and finished. We have the answer, so the answer is 1 by 6. But sadly, I am teaching you beta gamma, so I am not allowed to use this shortcut. So we do like 1 by 4, 1 by 2, beta 3 plus 1 is 4, 4 by 2, 2, 2 comma 1 by 2. And that will be 1 by 4 into 1 by 2 into gamma 2, gamma 1 by 2 by gamma 2 plus 1 by 2. That will be 5 by 2. And that will be 1 by 4, 1 by 2, gamma 2 is 1 factorial, that is 1. And we have root pi, and here also 3 by 2, 1 by 2, root pi. And anyway, we end up with the same answer, 1 by 6. Now let's try another problem of the same pattern. Evaluate the integral from 0 to pi. Oh no, here we go. It's not pi by 2. Sine to the power 6x by 2. Okay, we have some good news, because I can see that if I put t equal to x by 2, I will get pi by 2 and cos to the power x by 2 dx. I think now we got the pattern. So it is not from 0 to pi by 2, so we think we will not be able to apply the beta gamma trick. But when we look at the angle which comes along with sine or cos or sine and cos, okay, we will feel that when we put t equal to that and check the limit, yeah, If x equal to 0, t equal to 0 by 2, that is 0. If x equal to the upper limit, that is pi, t will be pi by 2. So we get integral t is equal to 0 to pi by 2, sine to the power 6t, cos to the power 8t. Wait a minute, I forgot something. Yeah, dt. dt equal to dx by 2. So that is 2 dt. 2 goes here and dt. That's it, my friends. So we get 2 into 1 by 2 beta. 6 plus 1, 7 by 2. 8 plus 1, 9 by 2. Gamma 7 by 2, gamma 9 by 2, the whole divided by 7 plus 9. What is 7 plus 9? 16. 16 by 2, gamma 8. And simplify, simplify, simplify. You're supposed to get 5 pi by 2048. Okay, now let's move on to a little bit harder question. So we have the integral. You can write as a question. Evaluate the integral 0 to pi by 6 cos to the power 4 3 theta sine square 6 theta d theta. Just when you think you have a pattern, suddenly you feel you're lost. In the last problem, the angle was uniformly x by 2. In the first question, the angle was 4x. That is uniformly, let's say 4x. There is no one else. But here we have 3 theta and 6 theta. Wait a minute, I have a trick. You just try this and check the upper limit. What is 3 into pi by 6? Yeah, I'm getting pi by 2. That means our substitution will be 3 theta. Okay, and that means I have to do one trick. Can you tell me what is sine 2 theta? You might have learned this formula long back, maybe in class 9 or 10. Yeah, that is 2 sine theta cos theta. Now imagine we have sine 2 into 3 theta. That will be 6 theta. So I can write that as 2 sine 3 theta cos 3 theta. And that of course means sine square. I'm squaring on both sides. I'll be ending up with 4 sine square 3 theta cos square 3 theta. And why am I writing everything in terms of 3 theta? Because I saw that if I substitute t equal to 3 theta, the lower limit will be 0 and the upper limit will be pi by 2. Okay, so I'm going to modify the question a little bit for my convenience. I will leave the first one as such, and the second one I'm going to replace with that yellow thing which we wrote here, that is 4 sine square 3 theta cos square 3 theta d theta. Now what will I do? I will put 3 theta is equal to t. And what are the two things which you should remember? Differential. 3 d theta is equal to dt. That implies d theta is equal to 1 by 3 dt. And the next one, if theta is equal to 0, t will be 3 into 0. If theta is equal to pi by 6, which we already know, t will be 3 pi by 6, that is pi by 2. Now time to plug in everything. Okay, so what should I write instead of the limits? Yeah, I have to write t equal to 0 to pi by 2. And 3 theta becomes t, and this 4 goes outside. And again sine square t cos square t and d theta. What is d theta? I forgot. Let's look at d theta. 1 by 3 dt. So that also goes outside, and that gives me 4 by 3 integral t equal to 0 to pi by 2 cos to the power 6t and sine to the power 2t dt. And that's it. That's all we want. 4 by 3, 1 by 2 beta. 6 plus 1, 7 by 2. 2 plus 1, 3 by 2. And that will be, this 2 and 2 will be cancelled. So we get 2 by 3, gamma 7 by 2, gamma 3 by 2, the whole divided by gamma 7 plus 3 is 10, 10 by 2, 5. And that is 2 by 3, 5 by 2, and 3 by 2, 1 by 2 root pi, and 1 by 2 root pi, the whole divided by 5, that means 4 factorial. So now you can simplify this and check if the answer is 5 pi by 192. So that's it, my friend. It is a small video and this is very important, especially when you learn applications of integration, or maybe next year or maybe in the next semester when you study some application, you might get stuck. At that point, beta gamma functions will or may help you. Anyway, I'll be back with the same type of problems but a little bit twisted ones. So we'll meet very soon. So till then, my friends, bye.